There are array monitor displays to show operational status of every module. Individual locator lights give a continuous check. Modular design makes replacement quick and easy. Like all other equipment, the displays provide room for system growth. A large amount of specialized equipment, like this video display console, must be installed so that the program of calibration may begin. An important step in this calibration cycle is the use of an electronically instrumented C-131 from RADC flight test. As it flies a predetermined pattern around the radar site, the aircraft establishes a data link with ground pattern measuring equipment. Operational returns are checked on the newly installed signal processor. This uses the scan within a pulse technique, SWAP, which provides significant advantages over receive beam clusters. The signal processor is a major subsystem which converts the receiver intermediate frequency target returns into digital words for computer processing. Another major subsystem is the radar programmer. It affects the real-time control and data processing in the radar complex. The Bendix 101 computer is an integral part of the radar programmer. It was especially designed to perform the real-time computations and exercise control over the signal processor and radar interfaces. Execution of the surveillance patterns, acquisition, and the real-time tracking of known and unknown targets are performed. Resultant target data is transferred to the system computer for final processing. The system computer, an IBM 7044, is responsible for all functions not intimately related to the radar control. It maintains a catalog of as many as 1,000 orbital elements on known objects, computing elements of new objects, handling data requests from space track control, smoothing the individual radar returns, determining an object to be a missile or a satellite, and supplying the resultant information both to the situation display and space track control center. The display consists of a geographic background and radar coverage outline. On it are automatically displayed the identity, altitude, and position of all unknown objects. Known objects are displayed on request, as are status and surveillance performance data. Radar data used in generating the display go to the ultimate user, the Space Track Control Center at Colorado Springs, via high-speed data link. Here, as part of Norad, the North American Air Defense, phased array radar will assume a vital function in our aerospace surveillance and warning systems. From Space Track Control Center will come requests which may include satellite detection or missile detection, recognition and specific or continuous track of old targets, observations and orbital elements on new targets, and many more. As an operational system, the FPS-85 can meet these requests, adapt to the required mode or mission, and do it instantaneously and automatically. Its beamforming, steering, and time sharing are electronic, and the answers are stored for immediate integration or later analysis. This it will do now. More important is its inherent growth potential. It is a significant advantage of phased array radar that this growth can be accomplished with virtually no loss of original investment. The future will bring more challenges in space and greater threats. To meet them will require that growth potential. Better measurement and resolution, increased range and target capacity, enhanced operational capability will be needed as space objects increase in number, range, and sophistication. The growth capability inherent in the FPS-85 will be adequate to handle a space population of 2,000 objects simultaneously in its coverage, and 10,000 orbital elements in its catalog.
CBS reports UFO, Friend, Foe, or Fantasy continues with Walter Cronkite. Much of science, when we look at it close up, looks like fiction. Those who charge a conspiracy as being carried on by scientists and the military to cover up visitations from outer space use that charge to explain why no UFOs have been reported by our space defense system. Well, this is a dangerous game, like yelling fire in a crowded theater. For in this hydrogen bomb and missile age, the Air Force has the job of turning the unidentified into identified objects in a matter of moments. There's no time for theory and conjecture, because any unidentified object would sound warning klaxons around the world. Thousands of people would have to know about it instantly. It's literally true that what we don't know could kill us. CBS News correspondent Bill Stott reports from Colorado Springs.
This is where they watch everything that flies over or close to North America. The Combat Operations Center for NORAD, the North American Air Defense Command. Thousands of items of information pour in here from radar stations, outposts, ships, and aircraft scattered all across the hemisphere. Data that's sorted and displayed on this screen. All routine flights, commercial and private, are filtered out. Those of special interest to air defense are shown as arrows. Yellow is the Strategic Air Command. Green is for special interest flights, such as President Johnson's plane. Orange is unknown. After they're identified, that color is changed. Red is hostile, a color used so far only in practice. All this and much more goes into the decisions that are made right here in this room. A 24-hour watch kept by men of the Air Force, Army, Navy, and Canada. They see everything that's in the sky. They have to. And one of them is Captain Gary Reese, an Air Force radar officer with the Air Defense Command. Is that right, Captain? You see everything that's up there?
Yes, that's right, Bill. With the characteristics of our present radar system, any object which has reflective surfaces and which stays within our radar coverage, which is virtually every square foot of the United States, will be painted on our radar screens.
But how good are you, Captain? How large an object can you see?
If it is reflective, and let's say larger than a watermelon as a crude example, and within our radar coverage, we should paint it.
You talk about the reflective properties of an object in the sky. Is it possible, Captain, that there are things up there, native material, your radar will not pick up?
So far as we know, all flying objects are composed of materials which are aerodynamic and which do have a reflective surface upon which radar waves can be bounced. It's possible that there are other types of material, however, I doubt it.
Has there ever been a report of a flying saucer, Captain, that was translated into hard information right here, a plot on the board in this room?
I don't think so, Bill, for the reason that these sightings have never been substantiated and could not be translated into hard radar return figures.
There have been sightings then, but they turned out to be other things, airplanes or balloons.
But never a saucer.
You see everything up to roughly 100,000 feet?
Yes, that's right, up to approximately 100,000 feet, at which point the space tracking network takes over.
The Space Tracking Network, also in Colorado Springs, is charged with tracking and logging every object that moves in space around the Earth, from 100,000 feet to 2,000 miles. Bill Stout asked Major Albert Morse just how good the surveillance is.
As an example of some of our precision, we have here a photo of an object re-entering the Earth's atmosphere. Through our programs, we were able to predict a precise time that this was going to happen and notified a particular agency who then went out with a camera and was able to obtain this photograph.
What altitude?
This is just entering the Earth's atmosphere somewhere around 400,000 feet.
In keeping track on this board, you follow not only hours, but Russian, Canadian, French?
Yes, sir. Everything that has been launched so far.
Could there be objects in the heavens that you cannot see?
Yes, sir, there possibly could be. However, if they do have a reflectivity to a radar and obey the physical properties, these can be tracked by our system.
How far out can you see, and how small an object could you see?
Our general limits are a 1 square meter target at approximately